Welcome back to the booth at OSCON. We're live here with Rich Gibson, which is just a wonderful treat for me. Rich is going to be speaking tomorrow with scientist Ann Wright, Thursday at 1:40 p.m. on Explorable
Microscopy.
Microscopy, bringing gigapixel imagery to the micro scale. Welcome.
Thank you.
Glad you're here. And you're with an outfit, well, you work with Gigapan, is that right?
With the research project of Gigapan at Carnegie Mellon University.
Okay, and can you give us a brief idea of what it is that you're doing? I mean, brief, because it's deep and rich and complex.
Sure. The Gigapan project came from Mars, where images were sent back from the Mars rovers, and then NASA stitched them together to make large, at that point, 70 and 80 megapixel images. Well, it turned out you could explore those images. You don't just look at them like you look at a normal picture, you explore them. And that mattered, and it made people care about Mars. So Randy Sargent and Elon Norbach, a few other people said, gosh, wouldn't it be cool if we could get people to care about the Earth, to care about the other people on the Earth? Right. And maybe if they had this tool in their hands, if they could take images that other people could explore, we would care.
Right.
And that idea has seemed to be true. The project has been going strong. There's a UNESCO project, there's Gigapan units in schools, which are just a small robot, costs a few $100s, holds a camera you might have in your pocket. It's a bigger rig that'll hold a DSLR for people who are hardcore. But then you can generate really easily 1,000 megapixel images.
And is that's one image, that's not the overlay that we were discussing before we came on camera,
right.
Is it?
No, that's not the overlay. So what happens when we try and take that same thing and go smaller is you have problems with your depth of field, the focus. The first summer, two of my colleagues, Molly and Jay Longston and Molly Gibson, adapted a Gigapan unit to control a scanning electron microscope. And it turns out captured some wonderful images. Tim tweeted about them, New Scientist blogged about them. Awesome images of ants, of barnacles.
Right.
I'll show some of them tomorrow.
Good.
Well, the scanning electron microscope, you don't have the same depth of field problems. So when we thought, let's take this to microscopes, and our colleague Gene Cooper started doing macro rigs, so using a CNC table that you'd normally make a CNC controlled router or something, he put a camera on it. And so at that level of shooting things at the macro level or through the microscope, you lose depth of field. When I'm shooting through the microscope, my depth of field is like 8 microns.
Wow.
Which is, the top and bottom of a human hair are not in focus. Right. So to handle that, you actually have this combinatorial explosion of images where you take a stack of images, click, 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 click at different focal planes, and then use clever software that we didn't write to put those all together to make one image. And then you move over and take another stack.
Right.
And then you take this whole array and put those together. The largest one that we've done, Gene took actually 50,000 18 megapixel images to take it. It's
and
probably,
what was that of?
This iridescent blue beetle.
Oh boy.
It was really good.
Yeah.
It was an article in the fall in New Scientist that had the beetle in it. It was the poster bug for the Gigapixel Sciences conference we had in the fall.
The poster bug. It's so fun. It's being used for real things. That I have seen this in the past before even hearing about you. I think it was a picture of Prague, or it was a European city of some kind. And as you went closer and closer, you could see into people's windows. It was crazy. It was just, it brought out the voyeur in me, but I'm as much a voyeur about ants and blue beetles as I am about strangers in Prague. And one of the things that you folks are doing is also working with colony collapse disorder, right? You're using this technology to go into a hive.
Yeah, so Gene Cooper has done just this great work building rigs at, a step above. It's all part of the Explorable Microscopy project, but a little bit a step above in scale. So and also because taking things at the resolution that the microscopes do, you'd need too many images. But he's working to be able to image a whole bee frame in, first it was 30 minutes, and now they're saying, well, can we do it in 15 minutes? So we have images of a bee frame. And there's a scientist, the Pennsylvania State apiarist, Dennis, I can't pronounce his last name, I'm sorry, it's Dutch. A wonderful guy though. And he gave a TED talk. So if you Google bees and Ted, you'll find him. But they're taking the bee frames out. They have one of these rigs out there, and they're doing them themselves. And imaging a bee frame every day, well, multiple bee frames, but every day for the 14 days, I think it is, between an egg being laid in a comb and it being capped over.
Right.
And I have some images I'll show tomorrow of just that show combs, adjacent combs with tiny little larvae, larger larvae that are just squishing the bounds of their cone walls, and then the capped over. And the idea is that what we can do is what Kevin Kelly described is a triple blind study. How do we, normally like the experiments are single blind. I know I'm doing a study, but you don't.
Right.
So I give you something or another. Or they're double blind. Neither of us know, or maybe they're triple blind. We're just living our lives, minding our own business. And then because we've collected data, in this case, Gigapan data, in the body track example that Anne's working on, it's sensor data, well, all kinds of sensor data we can get in that section, and then look afterwards for the patterns. So we can look back in a time-lapse sense and say, oh, it looks like the colonies that collapsed, at some point 2 weeks ago have this in common. They all had this parasite introduced, or they all had this stress reaction, or they all had or whatever the bee guys are studying.
Sure. So it's forensic in that way. It's it really is, isn't it?
Yeah.
Now you just mentioned what Anne was studying, and Anne is your colleague. She'll be presenting with you tomorrow, and she's going off. Sorry, OSCON, but she's not doing what she said she was going to do. What's she going to talk about tomorrow?
Well, our excuse.
Nice one.
Is that I'm boring.
Oh, Shaw.
No, our excuse is that Jay broke his ankle and Jean had a conflict, and I can't hold a talk myself. So we have Anne coming on. Anne was actually part of the team that did support for the Mars exploration rover. A huge amount of support, actually, and she did visualization work. Her husband, Randy, was the person, basically, who's, I think, most responsible for the Gigapan coming into existence as something that we can have on Earth. She goes way back. She's from MIT, originally. She's way back. But one of the things that happened to Anne is it turned out during the MER missions, and I thought this is funny, because they went on Mars time, they had weird schedules. So they were doing everything they could to keep the support crew sort of up and live. And one of the things they did is they had free ice cream 24/7, huge ice cream coolers. And Anne hypothesizes, because after the MER mission, she started to lose weight, a dangerous amount of weight. It was really a problem. And she hypothesizes afterwards that it was that ice cream that was keeping her from having these other underlying physical issues that were causing her to lose the weight, that was masking that.
Right.
So it kept her going for a bit. But out of this experience, and she had a phrase about dropping through the medical pachinko machine and emerging at the end. But she's reasonably, scientifically based, an engineer. So they've created this project, Body Track, which is part of the Create Lab, that has done is developing a number of hardware, open source hardware devices to help you, and integrating the data from other devices to help you integrate all of these data streams and look at them so that you can do basically triple blind studies.
On yourself.
On yourself.
So it's the quantified self.
It's absolutely
it's
absolutely the quantified self. Maybe not times 3. It's the same. They're working with, but working with the same people. Kyle McCullis, and they have a doctor whose name I don't recall, and really trying to work with a whole community. But the hook, and this is the part where there's an excuse, is that I've been fascinated with being able to explore. So my first OSCON, I talked about maps. The first, when Skylar and I were working, and Joe were working on mapping hacks.
And we're getting close to time here.
And now I'm really excited about them exploring time, having a timeline that lets you look at and explore what's happened over time.
It's all fascinating, and there's going to be a lot more tomorrow when Rich and Anne present at 1:40. Thank you so much.